Imagine you are at a massive crowded music festival with thousands of people. Among the fans there are undercover security guards whose only job is to spot anyone who should not be there. But here is the catch. Everyone looks almost exactly the same. How do the guards know who is a friend and who is a party crashing intruder? This is exactly the puzzle your body solves every single second. Inside you, an army of billions of immune cells is patrolling your bloodstream, looking for the bad guys like viruses and bacteria. But since those germs are often microscopic and can hide inside your own cells, the immune system needs a foolproof way to tell self from non-self. If it makes a mistake and attacks your own healthy cell, it is a disaster. If it misses a germ, you get sick. So how does it actually know who to attack? It all starts with a very special ID card system. Almost every cell in your body carries a set of markers on its surface called MHC molecules. These markers are unique to you. Unless you have an identical twin, no one else on earth has the exact same uniform as yourself. When an immune cell like a T cell or a B cell bumps into another cell, the first thing it does is scan that ID card. If the ID matches your body's unique code, the immune cell says, "My mistake, have a nice day," and moves on. But if it finds a cell that does not have the right ID, or if that cell is holding up a flag that says it is being hijacked by a virus, the alarm bells go off. But how do these immune cells become so smart in the first place? They are not born knowing the difference, they have to go to school. This immune school happens in two main places, a bone marrow and a small organ in your chest called the thymus. When your immune cells are first created, they are like eager but reckless recruits. Before they can control your body, T cell must pass through a final exam. In the thymus, they get a sneak peek at almost every protein, an ID card present in your body, from heart cell to brain cell. If a young cell, T cell, mistakenly attacks one of these friendly samples, it fails the test and is destroyed on the spot. Only the cells that can ignore your healthy tissues while remaining ready to fight off intruders are allowed to graduate and enter the bloodstream. This process is known as negative selection, and it explains why your immune system typically leaves your healthy organs alone. When a real threat like a flu virus or bacterium enters your body, it doesn't have a secret ID card. Instead, it carries its own unique fingerprints called antigens. You can think of an antigen as a bright neon kick-me sign that the germ can't remove. Your B cells and D cells have special sensors that are shaped just like these signs. When a cell the sensor clicks into a germ's antigen, similar to a key fighting in a lock, the immune cells knows it has found an enemy. It then starts to clone itself thousands of times, creating a huge army of specialized soldiers designed to hunt down every single germ with that exact neon sign. Sometimes the system is not perfect. In some situations, the immune system might overreact to something harmless, like peanut protein or pollen, which we refer to as an allergy. However, most of the time, this amazing biological security team operates flawlessly. It spends its days scanning billions of ID cards and checking for fingerprints, all to make sure that the only things being attacked are the ones that don't belong. If you found this video helpful, hit the like button and subscribe for more cool science and weird body